Greetings of the day, dear students. In this video, we are going to discuss about the speed control of three-phase induction motor. What are the different methods we are having? What are the different methods of speed control we are having? And what are its advantages, disadvantages? All those things we are going to discuss in this video. Right? So here, dear students, it is very important in order to control the speed of the induction motor. If we recollect our previous basics, the induction motor is going to have the stator and rotor, and the stator will be given the three-phase supply, right? And because of the applied three-phase supply, right, a resultant flux phi r will be developed, and it is going to get rotated in the air gap in between the stator and the rotor at synchronous speed ns. Now the rotor rotates with some speed n. So ns indicates the synchronous speed of the revolving or rotating magnetic flux, and n is the speed of the rotor. Already we have defined the slip s is given by ns minus n divided by ns. So obviously s equals to 1 minus ns by ns, right? So if you want to express the speed of the rotor in terms of synchronous speed ns, so n is given by 1 minus s into ns. 1 minus s into ns. But from our previous basics, we are familiar with synchronous speed ns. ns is given by 120 f by p. 120 f by p, where f indicates the supply frequency, p indicates the number of poles. So in the place of ns, if you substitute 120 f by p, so this is the final equation. This is very important. From this equation, we are going to classify what are the different methods of speed control for the induction motor we are having. I repeat again, the speed of the rotor n is given by 120 f by p into 1 minus s. So this formula itself indicates that either by changing the supply frequency, or by changing the number of poles, or by changing the slip s, we can control the speed of the induction motor. We can control the speed of the induction motor, right? Now let me go further. If the control is to be done, as we have discussed earlier, we are having the stator and the rotor, right? If the control is from stator side, it can be achieved by either changing the applied voltage, or by changing the applied frequency, or by changing the number of stator poles. These three methods comes under the control from the stator side. So if the control is to be done from the rotor side, we can achieve that using rheostat control method, or by operating the two motors in cascaded manner, that is in series manner, or by injecting some EMF in the rotor circuit. So these six classifications, methods we are having, either control from the stator side or control from the rotor side. Now let me see step by step what are the different ways to control the speed of the induction motor. First one is by changing the applied voltage. As we have discussed earlier, we are having the stator and the rotor, and the stator will be given the three-phase supply, right? That is nothing but some applied voltage we used to apply, right? Now the torque developed across the shaft, we are having the relation where the torque will be directly proportional to the square of the applied voltage. So by controlling the applied voltage, the torque output can be controlled. Once the torque is controlled, the torque power output P equals to omega t, right? So once the torque is controlled, the speed of the machine can also be controlled. Even though this is the cheapest and easiest method, but it is rarely used. This method is rarely used because for very small change in torque, very large amount of voltage is to be changed. There should be a large change in the voltage in order to achieve small change in the speed. So this large change in voltage will result again in a large change in the flux density. But the key point in speed control by changing the applied voltage is torque developed is directly proportional to the square of the voltage, square of the applied voltage, right? Next one is the we are familiar 120 F by P. So by changing the applied frequency, of course this is not that much easy. Once the government is supplying the power at some 50 Hz, by some external means, by using some drives, variable frequency drives, you are supposed to change the frequency of the supply. Instead of giving 50 Hz supply to the three-phase induction motor, some other frequency, by changing the frequency we can control the speed, right? But the thing is, we have to use some separate drives. So here, but a decrease in the, if you decrease the frequency of the supply, that means if you make it below less than 50 Hz, there will be huge amount of losses will occur in the core. Once there are more amount of losses, it leads to the heating of the machine, and obviously the efficiency of the machine also will come down. So if you are operating the machine at lower frequencies, that leads to the heating of the machine, and also it leads to the low efficiency. This is the drawback. So, and also increasing in frequency increases the speed, increases the speed. If you increase the frequency, the speed increases, and it is going to reduce the torque. And I have told you that we have to use the variable frequency drives in order to control the speed by using this method, right? So this is the speed control by applied frequency. Next one is the using the stator poles. Once the machine is designed, it is difficult to change the number of stator poles. Once the machine is designed, okay, it will be difficult to change the stator poles. But even though it is difficult, there is a possibility to, by changing the stator poles, we can change the speed of the machine. So how it can be achieved? The change of the number of poles is done by having two or more entirely independent stator winding in the same slots. The slots will be same, but in the same slots you will make windings in a different manner, right? So independent stator windings will be provided in the same slots. So each winding gives different number of poles, so we will get the different speeds. By having the different number of poles, right, we can get the different speeds. This is one method. Due to the cost and complex in switching arrangements, it is not practically implemented, right, to provide more than two arrangement of the poles. And of course this method is applicable to the squirrel cage induction motors only. As we have discussed earlier from your previous discussions, from stator and rotor again we are having the slip ring induction motor and squirrel cage induction motors, depending upon the construction of the type of the rotor, slip ring and squirrel cage. So this method is applicable to the squirrel cage induction motors only. Next one is the speed control by the rotor rheostat control. Rotor rheostat. Here this method is applicable to the slip ring induction motor only. We cannot modify the rheostat or resistance of the squirrel cage induction motor. Once its construction is completed, it will be difficult to modify the rheostat or resistance, or adding the resistances in series with the rotor will be difficult if it is squirrel cage. So but it will be convenient for the slip ring induction motor. So this method of speed control using rheostat control is applicable for slip ring induction motors only. So this can be achieved by introducing the external resistance in the rotor circuit. The speed can be reduced, and also the change in the speed depends upon the both rotor circuit resistance and also on the load. The load you have connected, depending upon the load we have connected and the resistance we have added, those two parameters are going to control the speed of the induction motor. But one drawback is, as and when we are bringing the resistances or rheostats into the picture, huge amount of power will be wasted in the resistors or rheostats, right? So there will be the power loss. There will be the power loss in the resistance. Whatever the current flows in those rheostats will be wasted, dissipated in the form of heat or losses, right? And also whenever the speed changes is required for short period only, this method will be used. For long period or long duration of time, if the speed changes are required, this method is not suggestible. This method is not suggestible. So due to the power losses in the resistances, this method will be used when the speed control is required only for the short duration of time, right? Next one is the speed control by operating the two motors in cascaded. Here what they will do is, two motors will be operated in series in such a manner that if you are having stator and rotor for one machine and again for stator and rotor for the another machine, for one motor the stator will be given the three-phase supply, right? But the rotor output will be given to the stator of the another machine. So its rotor will be connected to the stator of the other machine. For the stator where the three-phase supply is required, that supply will be obtained from the rotor of the first machine, right? In such a manner the connection will be made. They will be connected in series, right? Based on that, depending upon the number of poles of the machine 1 and number of poles of the machine 2, 4 different possibilities are possible. 120F by P1, that is one possibility. 120F by P2 is another possibility. 120F by P1 plus P2 or 120F by P1 minus P2, where P1 indicates the number of poles in the slip ring motor and P2 indicates the number of poles in the other motor. F indicates the supply frequency. So this is how we can achieve the speed control of the three-phase induction motor. Dear students, while in writing this essay in exam point of view, in this entire discussion, the important points or key points are the first basic, Ns equal to 120F by P, slip S equal to Ns minus N by Ns. Ns indicates the synchronous speed, N is the speed of the rotor. The speed of the rotor in terms of synchronous speed for induction motor can be written as N equal to 1 minus S into Ns. In the place of Ns, 120F by P is to be substituted. So either by changing the supply frequency or by changing the poles or by changing the slip, the speed control can be achieved. And if it is from the stator side, or if we are having the change of applied voltage by changing the applied frequency or by changing the number of stator poles. If it is from the rotor side, we can achieve it by using the rheostat control, rotor rheostat control, or by operating the two motors in cascaded or series connection mode, and by injecting the EMF in the rotor circuit. This is another possibility. And by torque is directly proportional to the square of the applied voltage. For small change in torque, huge amount voltage is to be changed. Large change in voltage is required. So this is the drawback. And by changing the applied frequency, if the frequency is brought low, losses will be more, efficiency will come down. This is the drawback. And variable frequency drives are to be used. By changing the stator poles, construction wise already once it is designed, it will be difficult to change the number of stator poles, but still it is possible by having entirely independent stator windings in the same slots. We can change the number of poles, but practically because of the cost and complexity in the switching arrangements, it is not practical to provide more than 2 arrangements of the poles, and this is applicable only for the squirrel cage induction motor. Speed control by rheostat control method, we used to add some external resistances, and this is not possible for squirrel cage. It is possible only for the slip ring induction motor, right? But the drawback is huge amount of power will be wasted in the form of losses and in the form of heat and losses, right? This is the drawback. And by operating in series mode, 4 different possibilities are possible depending upon the number of poles of the machine 1 P1 and the number of poles of the machine 2 P2. 120F by P1, 120F by P2, or 120F by P1 plus P2 and 120F by P minus P2. These are the different possibilities. So these are the points to be highlighted while attending this essay from the exam. And yeah, one more thing is left out. By controlling the injecting the EMF in the rotor circuit. So by injecting some EMF in the rotor circuit also we can change the speed. So this is instead of applying the resistance in the rotor circuit, this can be achieved by applying the EMF into the rotor circuit. So here the EMFs are applied by using the suitable source, and one more key point is those applied voltage frequency should be same as slip frequency. Instead of inserting the EMF in phase with the rotor, induced EMF is equivalent to the decreasing the rotor resistance. So by injecting the EMF into the rotor also the speed can be controlled. These are the different methods of controlling the speed, right? Clear? Thank you.